Hello, everyone. It's my pleasure to introduce Greg Law. Greg Law is the founder of Undo. He has over 20 years of experience in the software industry and has held development and management roles at various companies, including the British computer firm Acorn, as well as fast-growing startups like NextWave and Solarflare. Greg was determined to build a tool to help developers ease the pain of debugging complex software, so he founded Undo from his garden shed back in 2012. Undo is now established as the time travel debugging company for Linux software development. Over to you, Greg.
Emil, thank you. Thank you for the introduction. Sound check, you can hear me okay?
Yep.
Yeah, great. All right. Well, yeah, hello, everybody. Yeah, as per the intro, I founded Undo from the garden shed, and I'm delighted to join you from the garden shed today on this, what is a beautiful Saturday in England, Cambridge. I'm also really glad to be here because on Thursday, I tested positive for COVID, and yesterday I felt absolutely terrible. There was no way I could have done this talk yesterday, and today I seem to be okay. So that is a huge relief, and I'm just really glad to be here. And then also, if I do make any mistakes, then we can just blame COVID. Right. So without further ado, then let's kick off with the talk. So there's lots of content. It's going to be quite kind of quick fire. I'll just share my screen. There we go. Share screen. I'm going to share the desktop. There we go. So you can now all see some slides. Is that right?
Yep.
Good. Right. Okay. Please do. If anybody wants to chime in with any questions during the talk, then I'm quite happy to kind of take those questions. And I actually like it when these talks go a little bit kind of interactive and we kind of do some new stuff. It's always nice to mix these up. So please ask anything any time. Although note that I won't be able to keep an eye on the chat at the time that I'm doing this talk. So Hemil, if you could just sort of interrupt me at a convenient time as there are, as questions come in.
Sure.
Okay, great. All right. Well, let's talk about GDB. Well, let's talk about debugging actually. So debugging, actually, I like that there's a line that, but programming comes in two parts. There's bugging and debugging, right? There's typing the code in and there's making the code work. And as Hemil mentioned in the introduction, I always felt that there's just debugging is such an important part of software development. It actually dominates software development, and it's kind of overlooked, right? We don't spend, in my view, nearly enough time, invest nearly enough resources on debugging, which is basically half of programming. I mean, maybe you're a much better programmer than I am, but I think how many lines of code do I back myself to type in and have work perfectly first time? 10, maybe, right? If I'm really concentrating, maybe I could do 20, but generally speaking, it never works first time, right? And then we need to figure out why. And when it's a 10 or 20 line program, that's no big deal. You add some printfs, you stare at it, you'll figure it out. But most of us, when we're professional software developers, we're working on programs that are, at least typically hundreds of thousands of lines of code, very often many millions of lines of code. And you're trying to find that needle in a haystack, right? That one bad line of code. I mean, you've also got, perhaps millions and millions of lines of code, certainly hundreds of thousands of lines of code, and the computer's issuing, like billions of operations every second, many billions if it's multi-core. And you're just trying to find that one bad instruction sometimes. So if you think about it in those terms, it's kind of amazing that we ever debug anything at all, right? But to be really effective, we have to use the tools at our disposal. So Kernighan has a famous quote going back many decades, and where he says that debugging is twice as hard as writing the code in the first place. So if you're as clever as you can be when you write it, how will you ever debug it? Right. And that's a nice quote. And I think clearly what he's getting at is keep it simple. Give yourself margin for error, right? When generally as humans, certainly as programmers, we're not quite as smart as we think we are. But there's, I think, an interesting corollary to that line, which is if you take that to be true, which I think it is true, then what it says to you is that debugging debuggability is like the limiting factor in software development, right? So if you can make your code twice as debuggable, then whatever metrics we have for how good the code is, whether it's how fast it runs, or how maintainable it is, or how quickly we can write it, or how small, whatever the metrics for good is, if you're programming in a way that's twice as debuggable, you can make your software twice as good. This is quite an amazing thing when we think about it. So it's very important as programmers to invest our skills in using invest our development in developing the skills to use the tools that are available. So if you want to find a needle in a haystack, better to use a metal detector, right? If you want to debug code, better to use the tools at your disposal. And there are lots of tools, and there are lots of very good tools. And most programmers I find don't know really, they know only a very small part of the surface area of the tooling that's available. So what are we going to get into today? So in the hour that we have today, I'm going to just show lots of stuff about GDB. And my intention is I'm going to show you some stuff that you just didn't know was there, right? Even if you're a GDB expert, hopefully there'll be at least some things you didn't know existed. If you're not a GDB expert, there'll be a lot you didn't know existed. And the intention of this is it's not a tutorial, right? It's not a workshop. You're not going to come away from this being an expert. And realistically, maybe you'll be inspired to go away and try some of these things in the next few days, but we know how it goes. Probably you won't, but my hope is that you'll remember it when you need it. You won't remember how to do it, but you'll remember the thing exists. Because the thing with GDB is it's very powerful, but it's really lousy at discoverability, right? Now, info GDB is a sort of, that's the, or you can go and look at the documentation online from the same sources. It's pretty good, actually. The documentation is pretty comprehensive. The maintainers are very strict when patches are submitted. The documentation has to be updated. If it's a new feature, it has to be well documented. But like everything in GDB, it's only any good if you know it exists. Right. So my hope is we'll see some stuff, you'll know it exists, it'll sit somewhere in your brain. Then when you need it, when you're debugging that hard problem next week, next month, next year, you'll then think, oh yeah, I remember about that. No, I can't remember how to do it. Let me go and look online. You could also look, by the way, I have a bunch of small kind of bite-sized videos which cover some of the content that we'll see today, which we on something we call GDB watchpoint. So you can go and look at that series to refresh your memory so that you can actually use it when you need it. Okay. As I said, the middle bullet point, please help me improve this talk. I've given this talk a few times now. Every time I give it, I get feedback. Somebody tells me something I didn't know, and I can bring that into the talk and can bring it back. Because I'm not some sort of expert in this, right? There's lots about GDB that I don't know. This is just stuff that I've picked up along the way. So it's not intuitive for sure, and a lot of people hate on GDB. But it is actually, when you know what you're doing, very powerful. You can debug very difficult issues very quickly and with ease. So I think it's easy to use, but it's not easy to learn. And that's what we're going to cover today. And the first thing I want to talk about, we'll talk about a whole bunch of stuff, quite a quick fire kind of way. The first thing we're going to talk about is something called TUI mode, text user interface. Now, this is something that, apologies if you already know about this, but hopefully I'll show you something on this that you didn't know. But I find it surprising how little this is known still. I think this is the single feature of GDB that kind of scores the best on the combination of least well known and most useful, right? There are all kinds of graphical interfaces to GDB. You can use VS Code, you can use CLion, you can use DDD and Eclipse, and you can use it from Emacs, and they're all great. But when you just, perhaps you've SSH into a system and you're trying to figure out what's going on, you probably don't have that stuff available. You just want to fire up GDB, then TUI mode is very useful. So let me show you what TUI mode is. So I think we've got here a pretty standard hello world program. So let's compile that. Minus G3, by the way. I always like to do minus G3. It's like -G, but it gives you more debug information. And in particular, things like macros and stuff go into the debug info, and it's a bit better at dealing with some optimized code. It does make the generated binary a bit bigger because there's more debug information there, but it's worth it in my opinion. I hope that becomes the default at some point, but right now the default is -G2. So -G3, hello world. Okay, so let's run this in GDB. Okay, all kind of normal. I can do start, if you don't know, puts a temporary breakpoint on main and then does run. So just is a little bit less typing to start my program. Also normal. I'm using a relatively new version of GDB here. This is just what's installed on my system. It's we can see here it is oh yeah, look, it's in the pink text here. So this is GDB 11.1 because I'm running a relatively new install. What is this? This is 2110. So I get a nice newish version of GDB, which comes by default with the colors that we can see here, right? The kind of pretty colors. But still, if we go back to GDB here, you know, I've got just this one line of code. It's not a whole lot of context. If I type list, okay, now I can see my program and I can see where I am. I'm at line 6, but you know, this is kind of sucky, right? I mean, it's kind of okay with a hello world program if I've got any kind of complexity, especially if it's code that I didn't write or I don't know super well, then this is just not a very convenient interface, right? This is very much, this is kind of a green screen 1970s teletype type world. But if I go layout src, layout source, oh, look, here we are, screaming, as I like to say, screaming into the 1980s. So, you know, it's not pretty. You know, it's not, there's no nice dark mode UI here, but it is very useful. And the nice thing is you can just be SSH'd into a server on a terminal or whatever, and 2 mode is just there, layout source. Or I can do actually control, if I go control XA, that's a little shortcut, and I can toggle between them like that. Okay, so that's 2E mode, or I can actually start in 2E mode by, I can go like that. Okay, so that's kind of cool, right? I think very useful. One thing though you might notice it's a bit annoying is what I'm doing here, I'm hitting the down arrow and now hitting up. So if I hit up and down, usually what I do is cycle through the command history, right? This isn't doing it. This is moving the window up and down, which actually sometimes is useful if I've got a longer program than this. I can also go left and right, of course. But if you know, one of the most useful things about working from the CLI is being able just to go up the command history and edit and reissue commands. So I can do that here though by going Control P for previous, like that. Okay, and Control N for next. So you can go through my command history. Or actually, I can also do the focus command. So this is something I learned the last time I gave this talk. I didn't know about this until the last time I gave this talk, but someone came up at the end and told me about this. So I can go focus command, and it puts the focus on the command window. And now I can do up arrow and down arrow to go through my, so I can go focus source, and my focus is here. So that's kind of useful, right? But there's a bit more to 2 mode, even if you know about this. Here's some more to 2 mode. If I go Control X2, I get to look at my disassembly, which is very useful, right? And as I step through, step I, I'm sure you know, is step single instruction, does what you'd expect. If I can go Control X2 again, well, I get, because I've gone into the C library here, so I've got no source available, but if I type finish, we'll come back. Oh no, that's not what I expected to happen. Let's come. Oh, what I thought we were going to see is, oh no, we are in, right, okay, I've got myself completely confused. I'm going to restart the program. What I've done here is I'm inside the C library, so there is no source available. But if I restart the program, so that we've got source. So here we are. So I've got assembly and source code in the same view, which is kind of useful. If I go Control X2 once more, I actually get some register values. So now I can see the source code and the values of the registers. Control X2 again. Now I've got registers and assembly code, which can be kind of useful. So I can cycle through Control X2 again, and I get back to what I was looking at. So Control X2 sort of cycles through these different views in 2E mode. That's very useful. One of the things about 2E mode, though, is it is a curses program, and you know, like all curses programs, you end up cursing at it sometimes. It's, weird stuff happens, particularly because I'm running GDB here in the mode where I've started my program from within GDB. So if I attach my GDB to my program, then of course the terminal my program is using is different from the terminal that GDB is using. But if I type run or start from within GDB, now my program and GDB are sharing a terminal, and slightly weird things can happen. So I'm going to do next here, which is going to next over this printf statement, and watch. If you watch just sort of around here, I think we'll see it. Oh no, it didn't. Okay, it happened. Look, it's messed it up. Look at this. Now it says there are 2 printf lines, and that's not true. That's not what my program looks like. What's happened is my program's written hello world to the same terminal that the GDB was trying to do nice curses display, and it's just messed it up. That's okay though. I can just go Control L, and that reprints the screen. And whenever your program is doing output to stand it out, you'll probably want to do Control L to get things back. Okay, so let's just go over what we just covered. So I can go layout source or layout layout command or whatever to switch between those modes, or I can go Control XA, which is a little bit quicker, a little bit more convenient to toggle TUI mode on and off. TUI mode is part of, this is all very confusing, part of CLI. So there's a CLI mode, which is command line interface. Obviously, that's the sort of 1970s type view. TUI mode, text user interface, is that sort of 80s style. There's also, which is a completely separate thing, there's also a thing called machine interface, which if you're using, say, VS Code or CLion or something, that will talk to GDB over something called MI, machine interface, which is a different sort of command line interface, but it's designed, for front end debuggers rather than for humans. So that's just, and they're actually slightly, there's MI 1 and 2, and I think there might even be MI 3 now. But it's generally, you don't see them, that's what's happening behind the scenes. But if you kind of break into the debugger console from like VS Code, for example, you will be kind of exposed to that MI mode. So that's a different thing altogether. We saw Control L to refresh the screen. Control P and N is a useful way to get. Oh, by the way, as well as Control P and N, you can go Control F and B for forwards and backwards, rather than right arrow and left arrow, and Control E to go to the end of the line, Control A to go to the beginning of the line. So just that's normal read line. Most GNU CLI tools respect those commands, and Control X2 to get those different views. So that's some top tips for TUI mode. I basically use TUI mode all the time if I'm not in an environment where I have a graphical IDE. Right, let's move on. Oh, we got a question.
Not a question. So there have been a couple of comments. So the first one was Indranil's, who said that the TUI reminded him of the Borland C++ compiler interface.
Yes,
and
that's right. So yeah.
Next was my remark that the Control P and Control N reminded me of Emacs.
Yes.
And Nishant Patel says that you can just type refresh to refresh the screen. Ah,
there you go. I didn't know that. Cool. I've learned something new.
Indranil again says that you need to suspend GDB first and then issue refresh. Control plus L works without suspending.
Absolutely. Yeah. So I think I did it. I suspended GDB for just to kind of look at what was I doing. I can't remember why I did that. Some other reason. Absolutely. You don't need to suspend. RAC for refresh. Oh, interesting. Is that right? That's kind of surprising. Let's have a look at that. So let's restart the program.
Mm-hmm.
So, okay, if I do this next, okay, so now my screen's messed up. So what we're saying is refresh, enter, it sorts it out. So it doesn't look like you do need to suspend GDB first. That looks, unless by suspend you mean Control C to interrupt the running program, you certainly would need to do that.
Yep. Sorry to interrupt. There's also a question by Vivek that if GDB is applied to a running process, will assembly code be viewable in TUI mode?
Yes, absolutely. So yeah, so the way this works, I mean, assuming that the debug information is there. So if you compiled your program with, so we can do this. I think I have a program that runs for a little while already here. So this program, this is going to be a nice example, I think. So this little program is going to run for 30 seconds and it just runs a bunch of threads. So now if I look at PID of threads, I can see that's there. So GDB-P PID of threads. Okay, so here I've attached to my multi-threaded program. Here are my threads. And I can go Control-X-A. And no source available because at this point, if you look here, I'm deep inside the C library. So I would need to put a breakpoint. If I go frame 3, then that. Okay, maybe I've done a really bad thing and this program doesn't have source. Okay, there's no source. Oh, I haven't got the source files for this program. That's why. That was a bad example. I don't think I have a long-running program here, so I can't attach to something can't easily attach something with and show you. But yeah, basically it would work. If I'd done that, I could do TUI mode if I had source code available. Control-X-O to toggle the active window. Okay, I also didn't know you could do that. That's cool. So a bunch of shortcuts there. Yes, it looks like it does look a bit like Emacs, because of course originally it was written by the same person, right? Stallman did the very first version of GDB and of Emacs. So you kind of got that heritage there, and it's using, as I say, readline is the kind of the standard kind of utility where so that's what's actually dealing with. It's the same library that's doing the command line handling both in Emacs, I would think. Not actually sure on that, but certainly on most of the GNU tools. Cool. All right. Well, that's good. I learned a couple of new things there. So thank you for the participation. Let's move on because there's lots to cover. And that's going to talk about Python. So you probably know this, but may not have worked with it too much. But GDB has, for quite a few years now, has had Python sort of integrated with it. It's got a Python interpreter right there. So if I go into a little hello world program, so I can go Python, and I can just type some Python code. So I know print hello world. There you go. Now this is a pretty complete implementation of Python here. So I just show you, so just as a silly example, but I can import OS. I can print running on PID. Well, let's we're running on PID. Let's get PID. Oh, I didn't like that. Why didn't I like that?
Yeah, I'm missing calling Rosy Brace.
Thank you. So I'll go Python. Now I don't need to do import OS again because it is kind of stateful. So I'll show you what we mean by that. No, it's not. Oh, because that Python didn't work. Right. So yes, I do. Here we go. Finally. And this, by the way, this PID, if I Control Z there and look at this, is the same process ID, right? So the point of showing this is it's not like execing some Python and running some Python. It's actually built into that GDB, and that's useful because I can also, from my Python, I can do. Let's put a breakpoint on main, and now let's go Python import GDB. Print GDB breakpoints, and so I won't get it. So I can now start to interact. So there's a breakpoint set there, right? That is the breakpoint that we cared about. I can even set breakpoints. So I can go Python. If I create an object of the breakpoint class, and I need to give it a location, but I can just give it main. It'll be the same as the one that already exists. And the other thing I want to show you is that the state is kind of stateful. So Python, if I print it will have remembered. It's remembered that that BP object, that variable still exists, right? So there we go. That's kind of cool. I'm just gonna just bear with me. I'm just feeling. I think I said I was feeling completely recovered from COVID. I'm just feeling slightly strange, so I'm going to sit down just in case. All right. But usually I wouldn't be typing Python directly at the command line in GDB because, well, it's just too hard, right? It's too hard to get it right, apart from anything else. So I'm usually, if I've got more than a line or two, what I'll do is create a separate Python program and just source that. And you just source it, and you can source GDB commands as well, right? It'll just, GDB will figure it out whether it's based on the command, based on the file name, I think. And it'll work out whether it's Python or just normal GDB commands. So I can make a GDB script that does some regular GDB commands, or it can contain Python, and I can source it from the command line, just like we're doing here, right? So this is extremely useful, right? And if you work, we all work. Once you're working on a project that's any more than a, I don't know, probably 10 or 20 hours of development behind it, the code starts to build a certain complexity, and you find there are things you start just doing again and again from GDB, and you can script pretty much anything. I mean, the integration is pretty solid. The very odd thing I find very occasionally is something I want to do from Python but can't, but that's always a real surprise. It basically, if you can think of it and you can type it at GDB, you can script it from Python using that Python integration. If you're really stuck, you can always rely on the gdb.execute method from within the Python, right? So, I can do, I don't know, we can go, let's do Python gdb execute continue. And I've just run my program to the end, right? I could have done that directly from the GDB interface, but if I don't know how to do that, I can always just do this .execute and then type commands at it. Oh, there is a gray patch on Greg's. Oh, I bet I know what that is. That's probably, is that gone now? Is the gray patch at least in the corner?
I believe that's your Zoom window.
It's the Zoom window, yeah, right. So, okay, I need to close that. So the problem is I can't see the chat when I've closed. Yeah, I don't know why Zoom insists on doing that, but anyway, right. So hopefully you can now see that, okay. But does mean I can't see the chat. So you'll have to tell me when there's something when there's something in the chat and it's a good time to stop. Anyway, I'm not going to get into everything that's in Python. We could spend a whole day looking at all of the Python stuff, but just to know it's there. And I find useful is the you can look at the Python in the documentation, but the thing actually I find often more helpful is this Python help GDB. All right, so if I in Python, so for example, if I start regular Python and I go like import, I don't know, OS, and I can help, and it will give me the documentation on the OS module, right? Well, obviously from regular Python, if I go import GDB, it doesn't exist. But from GDB's Python, I can go Python import GDB and it exists. And I can go Python help GDB, and it gives me the documentation, all the doc strings for the classes and methods and everything else. And there's quite a lot here. You kind of have to know a little bit what you're looking for it to make sense. But when you know that, for example, there are breakpoints, so I can go like that, and now I've got the documentation for the breakpoint class, and I can see, these are the fields on the members on the class, and I can see here, there's a condition, so it might be a conditional breakpoint. It can tell me what that is, whether or not it's enabled, what the breakpoint was set as, right? So what we're breaking on, how many times it's been hit, like basically all of it, right? Everything that I would see when I go info break, I can also get by, and actually I think more than that, more information than that, but certainly everything I can see there, I can get by looking at the breakpoint object from the Python. But why would I do that? Well, who knows, right? But there are all kinds of reasons why you would want to do that. And I'm just giving you breakpoints as an example. You can, basically, as I say, you find yourself typing the same thing more than a few times. Think about writing it, putting it in a Python script. You can set. You can. I'm going to come back to Python in a bit if we get time. But I will just quickly say, because I'm not sure how we are for time. We may run out of time. So I'm going to say quickly on Python. The other thing you can do is to set pretty printers, where you can define Python pretty printers. Is a little bit awkward. If we get time, I'll have a look at the example of what you need to type to do it. But I tell you, it's worth doing. We always have, custom classes and data types, of course, and writing the pretty printers so that when I type print, foo, where foo is an instance of my class or struct or whatever, and having that print in a human readable way. I tell you, I guarantee you this: if you invest the time in writing some pretty printers for your project today, then your future self will thank you. And not too far enough in the future, you'll be glad you did. It's a really good investment of time. It's like everything. You have to take, a few hours out of your day, right, to actually do the pretty printers. But you'll not regret it, I promise. You can define custom hooks either directly from GDB or through the Python integration. Custom prompts, sorry. Why would you do that? Well, often we find ourselves running multiple GDBs at the same time. Actually, at Undo, because GDB is part of our product, essentially, it's one of the interfaces onto our time travel debugger is GDB. So we ship a version of GDB, and we find ourselves debugging GDB, quite a bit of the time, and because it's kind of part of our product. And so, but so that's really confusing. If you're debugging GDB with GDB, we would be using UDB. But if you're debugging GDB or UDB with itself, then which one you're in, you really want to set that prompt, because it gets completely confusing very quickly. But maybe I expect most of the people on this session aren't going to find themselves debugging GDB itself, but may well have multiple copies of GDB running in different windows because they're client server application and you're debugging both parts. And you can actually do that from the same copy of GDB, and I'll show you how to do that in a moment. But the easiest thing is just to run two GDBs from two different windows. And if you're doing that, setting a custom prompt is well worth it, because you just avoid that confusion of like, oh, which GDB is it I'm in? And if you want, you can do it from Python. But why would you want to do it from Python? Well, because you can then do arbitrary code here, right? So I can, like, whenever GDB stops at and gives you a prompt and waits for you to type something, you can then have this code execute. So you might want to update something. You can do that without the Python. Most of the things like this, I find it's probably easier to remember how to do it without the Python, but less flexible. But so I can actually define, GDB lets you define user-defined functions. So I don't know, I mean, I'm going to, I'm low on imagination today, but let's just call it my backtrace, and echo my own version of backtrace, and backtrace. Okay, and then now I've got this thing, this function. It tab completes, by the way. So and I tab BT, and okay, okay, let's do that again. There we go. All right. So that's how I can do a user-defined function. But I've got there are some special user-defined functions, hooks, and so I can also go define hook stop. That's a special function, and I could make that. I don't want to do another backtrace. Let's print the program counter whenever we stop. And so now I want to do next. Look at this. It's done. It's displayed the program counter here. Okay, so that's just a nice little way you can just do arbitrary commands when you stop. But you might want to do more than that. You might want to do something that doesn't, you need the power of Python, and then you can do it this way by defining this prompt hook Python function, and then just setting this global here that's part of the GDB module, and then that function gets called. Okay, so pretty printers, I just mentioned these. as you can see from the code here, it's a bit of boilerplate. It's a little bit tedious. I wish it weren't quite so tedious because it makes it kind of a barrier to people, doing it. You think, well, it's going to take me like first time I do this, I don't know, you might be a better programmer than I am, but first time I did this, it took me about 20 minutes, I think, maybe more to get it right. And then every time I try and do it, still it takes like 5 minutes to quite get it right. But as I said, what a fantastic investment in time that is, if you to be able to have your data structures and classes print in a pretty way. So I think we have an example of this here, because so let's see, I think I've got this program structs, and I think oh no, damn it, I thought I had a version of that in this folder. No, okay, I'm not going to, because it takes a while to get it right, I'm not going to do it in this tutorial. But you see, basically from here, what you do is you add the printer based on a regex, right? So you give a reg, so any type that matches that regular expression, it will then invoke the pretty printer for that thing. So just super useful. You should do it. Okay, so just some smaller things then. I'm going to get on to now little tricks and tips and tricks. But the GDB init file is probably about that. But you can have a GDB init file in your home directory, have one in the current directory. You can have a system-wide one. One bit of advice. Generally, I'd like to keep this talk clear of advice. I want to just make it practical, kind of how-to kind of tricks. But if I do have one piece of advice, if you will humor me on that, it's keep your GDB init files simple. Too many times now I've been, we've been supporting a customer, they get some really weird bug report, like, I don't know what's going on here, the thing hasn't worked, your tool's broken, and we look into it and we find that there's something weird in their GDB init. And more than once, actually, I've seen people have put run in their GDB init, like, and just like, oh my God, don't do that. because then, you do something like, you attach GDB-P attached to running program, and then it's trying to do a run from the GDB init, and just painful. So not what you're saving yourself. You only have to type enter, right? So don't put anything funky in your GDB init. Better, I think, to have files that you source, and you can then check those into your repo, to your project, and they're just there, and then you can source them, and your colleagues can source them as well. But there are some things, so my GDB init generally looks like this. So set history save on, that's pretty useful actually. So as I said earlier, I think one of the key things one of the things that makes command line interfaces just more efficient. Frankly, if you know what you're doing, command line is quicker than a GUI pointing, even if you've got all the command shortcuts, but certainly when you have to go to the mouse, just command line's quicker. And one of the reasons it's quicker is because of the command history, right, and the ability to just go and edit that. And if you set history save on, what that will do is save out a file by default called gdb.history. You can change what that's called. And when you quit GDB, it will save GDB history, and then when you start GDB, it will load it. If it's there, it will load it up, and therefore your history, your command history, persists across multiple invocations of GDB, which is just so useful. So you may even, if you were really eagle-eyed, you would have noticed that I relied on that when I was showing the TUI mode, Control-P, Control-N to go through command history. Okay, what I was actually, you've caught me red-handed here, because I just said keep your GDB init simple, and I have violated my own rule, and I've got too much stuff in here, and now it's caused me grief. So let's get rid of that, so I don't get this warning. Anyway, so GDB, and now if I go up arrow, these are the commands I did on previous sessions, right? Very, very useful to have those there. You don't get it by default. You have to put set history save on in your GDB init. Set print pretty on is I just think it's just a nicer way, right? So it'll just do a line per member or something on a structure. You may or may not like that. It's subjective. better to use Python pretty printers, as I say. I just find pagination gets annoying, so I like to set pagination off, and I like to set confirm off because I like to live life on the edge. If you're not living life on the edge, you're taking up too much space. So let's set confirm off. Actually, more seriously, I think the reason I do that is because most of the time I'm using, you just forgive me, a very, very small plug here. Most of the time I'm using GDB. I'm not actually using GDB, I'm using UDB, which is the GDB sort of interface onto our time travel debugger. And when you have a time travel debugger, the ability to like mess something up is drastically reduced. So you have much less scope for regret, because if you do the wrong thing, you can just go back. In fact, there's directly an undo command. So I just find the confirmations get annoying. You can have one thing you might not know. You can have a GDB init in your home directory. You can also have a GDB init in the current directory from where you type GDB. So that's a good place to put your project specific GDB init files. Maybe check that into your Git repo, whatever your source control you're using. You can also have a system-wide GDB init, and where that resides depends, unfortunately, on how GDB was built, right? So when you build GDB from source, -- configure, you give it some options. One of the options you give configure, sorry, not -- configure, you run configure. One of the options you can give configure is where the system-wide home directory will go. So of course, that means it all depends how GDB was built, which generally is going to be what distro you're using, because it's the distro who will have built GDB. But if I go, usefully, if I go GDB-H or --help, it will tell me where system-wide init files live. So this is Ubuntu, and if I've got etc GDB init, then I've got a nice system-wide GDB init file. I don't know why you would ever really use that, to be honest. You probably want project one or a per user one, but maybe you want to put it in system-wide. Okay.
Would you like to break for a second? There
Yeah.
are questions. Vivek asks, is Python a part of GDB, or GDB is calling Python from the environment?
Python is part of GDB. Python is part of GDB. So actually, that's a good point. So this can cause confusion, because that means it may or may not, it may not be the same version of GDB that's of Python that's on your system, right? Be whatever version of Python was kind of that GDB was built with. So if you're using the default GDB for your distro, as I am here, and the default Python for your distro, then it'll be the same. But if you're using a different version of Python, actually I'm probably going to be using PyEnv, so I probably do have a different version of Python. It can get confusing, because when GDB doesn't contain all of the system modules. So if you go, I did in that little demo, I did import OS, and that will import the OS module from my system. And yeah, if that is a version mismatch with whatever version of Python is compiled into GDB, I get weird errors. So if you find, you're unable to invoke the system modules, that is generally it's going to be because you've got a version mismatch, and you've got to be able to point your modules at the right Python version. But that's Python is inside GDB, and so maybe a different version than your system Python.
So next question is by John McFlaren. Can you use Python or some other technique to step over third-party libs? For example, step from findif straight into the predicate lambda without seeing the standard library frames?
Yes, you can. So you can. I'm not brave enough to try and type it in for you on live, but I'm sure you can do that. So you can use the Python to look at where I am, for example, right? So I can get the current frame from Python relatively easily. I can at least show you that. So if I go Python help, I can get a frame object, right? Which I can do by calling get. I can't remember now. There is a way to do it. I can basically, here we are, selected frame. So there's a GDB function, so I can go, so this function here, selected frame. So if I go, so it's okay, file a.out start Python. Well, that hasn't worked, but didn't tell me very much. So I can get like this, the selected frame, and I can, from that selected frame object, you can look at the documentation, you can figure out where you are, and you can figure out, well, actually now I'm inside some third-party thing I don't want to be. Then I can issue some finish commands to get it back to where I was. So yeah, I'm sure you can do that from Python.
There's one more question if you would like to take. Can we use Python, external Python packages with GDB's Python?
Only if the version matches, right? So you need to know what version of Python you're using, which you can do, can't you? I can't. Can anyone remember from Python how you find out what the version is? You can do it, can't you?
Python -- version. Python.
Well, no, but you can't. I can't do Python -- version here because it's. But from within Python, I can.
I guess system. It was there in the system module, but I don't remember exactly.
Yeah. Okay. So there's a way. Anyway. So like, yeah. So you know. That's it. Won't like that, but I can go Python import system. Is it like that? No. Anyway, it's sys, isn't it? Not system. So we can figure it out, and there we go. So this is Python 397, which probably is not quite the same version as is on my system, right? And that's because I'm actually inside PyEnv here. So if I go PyEnv deactivate, and then I can, no, still 3.10.0. So you can see it's almost the same, but not quite, version of Python. So you know, if you try and import too much, if you try and import simple modules, mostly it'll work because the differences aren't big enough. But if you get too funky, you'll probably get into trouble. So yeah, that's as long as the Python versions match, then you can import arbitrary modules, you know, custom modules you've made, or you know, system modules or whatever. Okay.
Yep.
Right. Let's move on then. So remote debugging. So remote debugging is this is pretty simple to show just how this works. But if you're, you know, you might be GDB is often used to debug embedded targets, right? And I maybe don't have a full, you know, maybe I don't have access to the source code on my embedded target, for example, right? And so remote debugging is useful, but also maybe my embedded target actually isn't that powerful, right? I can't actually run all of GDB and everything that requires an SSH onto my target because it's just like a tiny device. It doesn't have all that stuff, but I can run a GDB server on it. You can actually make your own GDB server, and it's pretty easy to do. And you only need to respond to, it's like 4 different commands that are required: step, get registers, set breakpoint, continue, I think, and maybe 1 or 2 others. And then you can do a minimal GDB server implementation. A lot of the stuff won't work. A lot of the, you know, more advanced features that we've seen today won't work, but really simple debugging will then work. So if I've got a target, I can't run Linux on my target. I can just make my own GDB server, and that's quite a common thing to do. Or maybe, yeah, I do want to do remote debugging because I don't want to run all of that. My target's running some of Linux, but not all of it. So what do we mean by that? So I run this separate GDB server thing, right? So if I run GDB server, I have to give it socket and port to listen on for connection and a program to run. So it's not actually started my program a.out. That's still my hello world thing, I think, but it's ready now. It's listening on port 2000. So if I now get another window here, now I can run GDB. I'm going to give it the same, so it knows what it's running, but I've noticed I've not typed start or anything, so it's not actually running the program. So now I can go target remote Now I've only got one computer here, so it's not really remote debugging, but of course this could be a different, it's trivial to make this not localhost to be something else. And okay, so now I've connected, and look, now it's actually started. A.out is right at the very beginning of time here. It's before main even has been called. I can now do all the normal things I would do, but so I can now continue, and it will run this program. And look, it's printed hello world, and now it's exited. Okay, so that's very, very simply how you do remote debugging. You can do a lot more advanced stuff than that, but that gives you a clue for what's there, how that works. Let's quickly, because we're kind of getting through time here really quickly. So I want to go through, there's a lot of useful stuff with breakpoints. So break foo to stop at a function, but I can do tbreak. Actually only worked out in the last call. Tbreak is kind of cool. If you're, as a Brit talking to Indians, I think we all like our T-breaks, but T-break isn't a T-break, it's a temporary breakpoint, but we'll remove the breakpoint when you get there. R-break is really cool. R-break is a regular expression, so that will break on any function that matches the regular expression that you give it. So, you want to stop on every function that starts with str in your string library. You can go, let's go r-break str.star, and interesting. I would have thought that would match, but maybe because I don't call any of the, I haven't actually. A.out start. So now when I go r-break, there we go. That's what I was expecting. There's lots of functions that that match the regular expression str, but it's put a breakpoint on all of them. It's probably not quite what I wanted, but you get the point. I can stop only on certain threads. Conditional breakpoints are very useful. I use these a lot, right? Break foo if bar more than 10. So it actually will stop internally when it hits that function bar, but it will only return to the GDB prompt when it hits the function foo, sorry, it will only return you to the GDB prompt when the expression returns non-zero, otherwise it will silently continue. So it just saves you setting a breakpoint and then, continue like 100 different times until you get to where you want to be. You can just program that into the expression and go to where you want. And I can delete and disable breakpoints. Disable without any argument I find quite useful. Disables all the breakpoints. So if I just I've got a bunch of breakpoints set. I want to go to a particular place. So I can just go disable, then set the breakpoint I really care about, then continue to that point, and then enable, and then I've got all my breakpoints back. Watch points, similar to breakpoints, same kind of thing. So I can watch on an expression. So these will run, you let the program run until the data changes. Watch -L actually is probably what most of the time what you want. So watch foo will watch the expression. So if I go watch foo points to bar and then continue, it'll actually stop when that expression changes. So it will stop if foo changes or if foo points to bar changes. But watch -L will just watch that memory address. You can also do that by just taking the address and watching star address, but watch -L is just a little bit more convenient. If you remember, our break on any regular expression match. So we've got our watch, which actually does something completely different, nothing to do with regular expressions. That's a read-only watch point, a watch for read or write. So our watch, if the hardware supports it, will stop when the value foo is read, is accessed, well, is read and not written. Thread specific and conditional watch points work just like thread specific and conditional breakpoints, and delete, disable, and enable work. It's the same space actually. So if I go, so I've got 212 breakpoints here, but if I go, I haven't really got anything I can watch, but well, I can be really silly and watch program counter, and you'll notice that's watch point number 213. So it's the same sort of namespace as breakpoints. Catch points are cool, so I can catch system calls and everything else. Running out of time, so I'm going to show you. I'm going to show you. We'll come back to that if I get time. Multi-process debugging is quite cool, so I can debug multiple things at the same time from GDB, multiple inferiors at the same time. We might get time to show that. I want to show another. want to show another thing first. So this is probably this is my favorite demo of bit of time travel debugging, which is the inbuilt reversible debugging that GDB has. I've got a function here, I've got a program here called sort, which doesn't do anything, but actually what it does is gets an array of random data and then sorts them using this bubble sort routine, right? And then returns, doesn't print anything or do anything, and looks to be fine. But I know that, because I've done this before, if I run this enough times, this will segfault. Might take a couple of seconds. There we go, segfault. So what have we got here? So we've got a core file. So let's load up that core file. Useless. My core file is useless. Probably some sort of stack corruption, right? So I've just got no idea. I've got nothing. The information about what I needed of my program is gone. So what I'm going to do is use the inbuilt GDB reversible debugging, time travel debugging, it's generally called now, to do a little bit better than that. And I'm going to use a couple of the things that we do. I'm going to attach some commands, some breakpoints, and do some yeah, let me show you, but easier to show you than just talk about it. So so if I just start, and I can do record. So this now enables GDB process record. Now I can continue, and it's got to the end, syscall exit. So I'm going to stop here. So now I've got a whole set of new commands like reverse step I. So this will go backwards one line of code. I can keep stepping back. So it's very, very powerful, because when I'm debugging, I'm really asking, how did that happen? And so time travel debugging just lets me see that directly. But this is an intermittent failure, right? We hate these. These are always horrible when it's intermittent failures. So what I want to do is just run this again and again and again with recording until I catch it in the act. So I'm going to put a breakpoint on main. I'm going to put a breakpoint on end. No, I don't mean end. Exit. And I'm going to put some commands on that breakpoint main. I'm going to go record, continue. So when it gets to main, it's going to enable recording and continue. And I'm going to put commands on 3, which is just going to be to rerun it. So if it gets to exit, gets to the end without segfaulting, we're just going to try again. I'm going to go set confirm off, of course, set pagination off because I can get in the way, and continue. So it's now ping-ponging between these two breakpoints. When it gets to the exit breakpoint, it reruns it, and then now it's, it's an intermittent issue, so it's going to take a little while. You can see, by the way, it goes very slow, which is a bit, one of the things with GDB's inbuilt reverse debugging, time travel debugging, is it is very, very slow. What it's doing is single step each instruction and then see what changes. But if we're patient, it will stop. Look at that, just on time. So now backtrace, just the same as looking at my core file, right? So this is kind of like looking at a core file, but remember, I've got the reversibility here. So I can go reverse step I, and look, let's go Control XA. Look, I mean, this not that surprising. I'm in the return at the return point. If I look at the assembly code, where are we here? Yeah, we're at a ret instruction, right? Now ret on x86, it's a full descending stack, so it's going to return to what is at the top of the stack. So if I look at the stack pointer, and I can go, so let's look at what is there. So like that, sorry, like that. So that's what's at the top of the stack. X for examine the memory. Let's look at what's there. Yeah, so there's garbage at the top of my stack, right? That's why my program crashed. That's not surprising. Why has that happened? Why is there garbage on the top of my stack? Well, I'm going to go watch star long star of that, and that's now going to set a watch point on that location on the stack. So watch points, if you haven't seen watch points before, it's like a data breakpoint. Okay, you run until the data changes. I want to know what changed, what corrupted my stack. So I'm going to run backwards until the data changes, right? So let's go, actually, let's just, before I do that, let's get back to that view. Okay, so reverse continue. That's not what I expected to happen. What did I do wrong? Got that wrong somewhere. What that should have done anyway is stop. There is a bug in this version. What it should have done, that's very disappointing. What it should have done is stopped here when it overwrote that location in memory. But why did it not? Did I get that right? Have I done something wrong here? So I've got a watch point. I don't know why it's not hitting that watch point. That is bizarre. Huh. All right, don't understand that. That usually works. But hopefully you can kind of see what we're doing here. You know what I'm going to do? If we've got time, I'm going to show you what that would look like in a version that's not buggy. This isn't deliberate, I promise. Okay, fine. Connect to a key server. So start. So what do we do? Break. I don't need to enable recording here, by the way, because it just happens by default. So I can put breakpoint there, command to run and set confirm off, set pagination off, and continue. And this is actually, you can't really see how much faster this is because it's well, it is a lot faster. So so we've now hit this the same as before. I can go reverse step I, and so if I go print what's it there? So that should be what we saw. So that's that bad address. So if I go watch star long star star, and we reverse continue, that's what should happen. So now it's stopped inside this array. So that's where it's smashed the stack. And what's happened? Well, print I is 35. What is array? Array is a thing of 32 elements. So I would index past the array, which I've done because I've done this percent size of, which is the size of the array in bytes, not the size of the array in elements. Anyway, that I think takes us to the end of time for this, or just slightly above. Loads more I wanted to show you. I'll make the slides available. Maybe next time we can do a part 2 of this. We kind of, but I liked that we had lots of questions and it went a bit interactive, and we kind of explored some stuff, and I learned some stuff as well.
Well, there are no more questions. Anyone has anything to ask?
Can I just, I have got this right. This is an hour session, isn't it? We are kind of out of time.
Sure.
Yeah. Okay. Well, let's hopefully do a part 2. And I look forward to doing that.